numbers. Thank you very much, those who posted already. We're going to start with our session for today, which is chi-square test. We're going to look at two chi-square tests. Chi-square test in the first half, we're going to look at goodness of fit. And then in the second half of the session, which will take us also about an hour, we're going to look at the contingency table, which tests for independence. And we're going to have a little bit of a break so that then we don't sit and stay at our PCs forever, so that then we can go and have a refreshment or go to the bathroom or do something or stretch or something like that, because we can't be sitting for 2 hours. Okay, welcome to your fourth session. I'm going to start with chi-square for goodness fit test. And since we started with the other part and we looked at hypothesis testing, we're going to continue looking at how we do hypothesis testing for this kind of a test, a chi-square test. By the end of the session, you should be able to know how and when to use chi-square test for goodness fit. When we do chi-square, in general, chi-square test, we are testing whether the selected sample data fit into a pattern. For example, with this, it should fit into a distribution called the chi-square distribution pattern. So that's what we're going to be testing. And with this method, we would like to see whether, for example, if you have, for example, with this one, it looks at the birth of children. So if we look at if the birth of children are evenly distributed across the year, or we can look at the ages of people if they are distributed across the company or something like that, across the division or across the years and so forth. So you look at one variable, but you want to test if that distribution of that follows a chi-square distribution. Like I said, we can also look at the age, and this method also can be used to test if something is fair. So for example, we can test the fairness of rolling the die or tossing the coin. We can use a chi-square distribution because for every time you roll or you roll that die, you can count how many times it falls on some head or tail or something like that, and you record those, and then you test whether they follow a chi-square distribution. Because we're going to be doing hypothesis testing, with the null hypothesis, we're always going to test that the population fit the distribution, which is the chi-square distribution. So we're going to say whether the population, for example, because we're going to be doing a goodness fit test, we're going to say whether the proportions of each category fits the distribution. Are they equal? So we go, if we have January until February, are we going to say the proportion for January is it equal to the proportion for February? Is it equal to the proportion for March? The proportion for until we get to the December proportion? They all need to be equal. So we test that. Then the alternative will say the proportions, at least one of the proportions is not the same. And that's what the alternative will be. It will test the it will be the contradiction of the null hypothesis statement that you have done. So let's look at the other things that you also need to know before you start doing the goodness fit test. For example, when we test, we need to calculate the test statistics. Like with the hypothesis testing, remember we said we need to know the 6 steps. Yes, with chi-square test as well, you will have to know all the 6 steps of hypothesis testing before you carry on and doing the analysis and making your conclusion. You will need to first state your null hypothesis and your alternative hypothesis. You will need to find the critical value. You will need to calculate the test statistic, and then you will also take the critical value and the test statistic and make a decision, and you also need to make a conclusion. So you need to know those steps. You need to identify what you are given in the question in order for you to be able to do the hypothesis. With the chi-square test statistic, we use this formula to calculate the test statistics, which is the sum of your observed value, because they would give you the observed value. Then you will have to calculate the expected, which then you will have to subtract your expected value from the observed value and square the answer, divide by the expected value. And because it's a summation, you will do for every individual observation on there. So let's say we work on January until December. So you will get your observation for January, but you need to go and calculate the expected value for January. And I will show you how to calculate the expected value, because when we calculate the expected value for the goodness fit test, we use the probabilities, but we will get to that. So you will take the observed value for January minus the expected value for January that you would have calculated. The answer or the difference, you square that, and then you divide by the expected value for January. Then you go to February, you do the same. The observed value for January minus for February minus the expected value for February. You square the difference, and then you divide by February. Then you go to March, you do the same. And once you are done, you add all of them from January until December. You add all of them, and that answer you get, it will be your test statistic that you would have calculated. And when we go and find the critical value, we need to always remember that, for example, with the goodness of test, the chi-square always have a degrees of freedom that you need to go and use on the test statistic table. When you go find the critical value, you will have to use the value of your alpha and the degrees of freedom. Okay, so to make a decision, since you would have went and found your critical value, which will define, your critical value will define your area of rejection, where you will have to reject your null hypothesis when the test statistics falls in that rejection area. For example, you will go to the chi-square table and go find your critical value, chi, alpha, and the degrees of freedom. When you have that, you come and you draw this diagram and you define the area of rejection, because if it falls on the red shaded area, which is greater than your critical value, if it falls in there, if your test statistics falls, or the value of your test statistics falls in that red area, you're going to reject the null hypothesis. But if it falls in the white area, which is the site, which is our do not reject area, then you do not reject the null hypothesis. And that's how you're going to use that to make a decision. So let's look at an example. Let's say we have this data. It's the sample of babies born in a city in 2015 till in 2015 from January until December. So we have this data, we recorded, and we counted how many babies were born in each month. And that is the table we completed. Now we need to test at 2.5 level of significance, which is our alpha value, whether the number of babies born in this city is evenly distributed throughout the year. So we want to know if this follows a chi-square distribution. So the first step we need to do is we need to state the null hypothesis, and that's what we need to do. We need to state the null hypothesis, and our null hypothesis, an alternative null hypothesis will state the numbers of babies born in the city is evenly distributed throughout the year. And that's how you state your null hypothesis. To state your alternative hypothesis, the number of babies born in the city are not evenly distributed. So it will be the opposite of your null hypothesis. The next step, if I look at my table, so for example, even in the exam, when you look at the table, it will look somehow almost like this. They might not give you the total. The first step that you need to identify here is there is no total, then quickly you calculate your total. So if you add all these values, 24 plus 23 plus 20 plus 18 plus, you add all of them. When you add them, you will find that the total is 252. And you write it there, 252, because you will need this total to calculate the expected value. Now, to calculate the expected value, because if I have this, they will have to tell you what is the probability of each month, or you will have to calculate the probability of each month. Because I know that January has 31 days, then I can calculate the probability of January. And use and calculate the probabilities. And then when I have my probabilities, then I can calculate my expected value. So January has 31 days out of 365. That will calculate my probability. And we do the same. February has 28 days. We're not counting the leap year. Let's say that year 2015 was not a leap year, so it has 28 days out of 365. You do the same with March, has 31 days, and it will be that. So the probability will be 31. Let's get the right probability. 31 times, or 31 divided by 365, and that gives us 0, 0.849, because my calculator is on 4 decimals. Let's put my calculator to 2 decimals. It will be 0.08. If I keep my calculator to 2 decimals, this will be 0.08. Okay, and then you do the same. The probability for February will be 28 divided by 365, which gives me 0.08 as well. So this also gives me 0.08. I kept my calculator to 2 decimals. Then I can take my probabilities and calculate my expected value. And when you calculate the expected value, we take the probability and we multiply by the total. And when you do that, you will find that these are your distributions. So you will say your expected value multiply by the 258 for 24 will give you 21.40, and you go on and you go on. And March has 31 days. That is why all the values with 31 days, you will see that they are the same. Then those with 30 days, for example, like April has 30 days, so you will say 30 divided by 365, and it will give you the answer 0.8222, and you multiply that with 252, and that will give you 20.71. So remember, when you calculate, please leave all your decimal places, because if you round off quickly, like for example, I've rounded off, for example, if here I've rounded off quickly and I said the answer is 0.08, you will notice that this will also say 0.08, and therefore it means your expected value will be the same throughout. But if you keep all the decimals, you will notice that 31 divided by 365, it will be different to 30 divided by 365. And if you take the answer for 31 divided by 365 multiplied by 252, you will find that it is 21.40. And if you take the answer for 30 divided by 365, you will see the answer will be 20.71. Okay, so once you have your expected value, then we are able to calculate our test statistic. Remember now, the formula to calculate test statistic, remember, it's your expected value. So for chi-square test, it's your observation minus your expected value squared divided by the expected value. What does that mean? It means since we have our observed value and our expected value, we're going to do some sums there. So it will say 24 minus 21 rand 40. Oh, not 21 rand. Why do I like money? I don't know. 21.40. 21 divided by 21.40 squared divided by 21.4 plus, because you're going to add all of them, and then you're going to say 23 minus 19.33. You square the answer, divide by 19.33 plus, and you do all of them. 20 minus 21.40 squared divide by 21.40. And you complete the whole thing until you get to the end, excluding the total, which is 29 minus the expected of 21.40 divide or square. Remember to square that, divide by 21.40. Once you have done that, you go and you start working out. And when you work it out, you will say 24 minus 21.40 equals, and you square the answer, and that gives you 6.76, and you divide that by 21.40, and the answer you get will be 0.3159 plus. And you do the same with the next one, which is 23 minus 19.33 equals squared equals, it gives you 13.47, and you divide that by 19.33, and we get the answer of 0.66968 plus, and you do all of the values that I can do. April, you do that. May, June, July, August, September, October, November, until you get to the December one, where it is 29 minus 21.40 equals, square the answer, get 57.76, divide that by 21.40, and the answer you get is 2.6991. Then you're going to add all of them, and when you add all of them, the answer you will get will give you 7.772. And that's how you calculate the chi-square test. The sum of your observed minus your expected squared divided by your expected will give you 7.772. Now, we have the test statistic. The last thing that we need to do now before we make the decision is to go find the critical value. How do we find the critical value? The critical value for this table will be, because there is one row and there are 12 columns, then it's 12. Our critical value will give the degrees of freedom will be 12 minus 1 because it is R, then, sorry, column minus 1. So our degrees of freedom will give us, our degrees of freedom is the column minus 1 or n minus 1. We can call it n minus 1 because there are 12 of them. Let's say it's n minus 1. So since our degrees of freedom is n minus 1, and we know that our alpha, remember our alpha from the question, it said our alpha is 0.025 because it was 5 divide that by 100 will give you 0.025 because our alpha was 2.5%. Remember that from the beginning, the question was with alpha of 2.5%, and that gives us 0.025. And we're going to go to the chi-square table and go find the chi-square on the critical values. So we go. And we go to one of the tables. Hide that. And we look for a table called critical values of chi. And this is the table. I'm going to make it bigger so that we can all see it clearly. And the table is called critical values of chi. Then we know that we are looking for the critical values of chi table. We're looking for alpha, degrees of freedom of chi square. Our alpha was 0.025 and our degrees of freedom was 11. So we're looking for the alpha value of 0.025. We're going to find it here at the top, and that's our alpha. And we're going to look for our degrees of freedom on this side and our degrees of freedom of 11. And where both of them meet, that is our critical value. And that is at that point. And our critical value is 21.9. And we go back. And our critical value is 21.9. I used another table, that's why I get 21.92. So yours has only one decimal, so it's 21.9. And that is our critical value. And then we can draw, because it's a chi-square distribution, it is right skewed. So that is why my tail goes like that. And we can define our critical value and our region of rejection. So we know that our critical value is 21.9. It falls there. Anything that falls in the shaded area, we're going to reject. And anything that falls in here, we do not reject. Anything that falls in that white area, we do not reject. And where does our test statistics, it falls in the do not reject area because it's less than 21. And then in our conclusion, and when we make the decision, since our test statistics is in the do not reject area, then the decision is we do not reject the null hypothesis, and we can conclude that our data is not sufficient to claim that the number of babies in the city is not evenly distributed. And that is how you do chi-square for test. And that is the last time you hear me talk as well. Any question? Please remember to put your name, not your name, your student number on the chat if you haven't done so. Do you have any question? Was it clear? Anything you didn't understand? Anything you need help with to make it easier when we do the exercises? We have 4 minutes before the end of the session, then you start doing your exercises. Do you have any question? No questions. Okay, so in the absence of questions, it gives us time to exercise. And there is your first exercise. You have 10 minutes to do this, and then when you're done, we will come back and do it together. But please make sure that you do the exercise. There is your first exercise to do. Feel free to ask if you're not sure. Who's still busy? Who is still busy? Guys, you need to talk to me. You can't be silent forever. If you don't want to talk, please post on the chat then and tell me I'm still busy or done, so that I don't have to speak to myself all the time. Please, guys, who is still busy? Okay, so it seems like it's only Peter who is online. The rest of you left the session long time ago as soon as you joined because you're not corresponding with me. So I don't know how we're going to do the exercises if I don't know if you understand anything or not. Because if you don't talk to me, how am I supposed to help you understand? Okay, let's do the exercise. Given the null hypothesis to be tested for the distribution, our null hypothesis P1 is equals to 0.2. So they give us as well the probabilities. So the probability for number 1 is 0.2. The probability for 2 is 0.4. The probability for 3 is 0.3. The probability for 4 is 0.1. So it means we're testing that the probabilities are the same, or the proportion for all P1 till P4 are the same. So it means the alternative will be they are not the same. So we're testing this. Then they also give us the observed values in the table with 1, 2, 3, 4, and the frequencies or our observed frequencies are 39, 78, 64, and 19. They also tell us at 5% level of significance, so we have our alpha. At 5% level of significance, use goodness of fit test to decide whether the distribution of the variable differs from the given distribution. Which one of the following statement is correct? I will say we'll pick that for now. We work through the statements and then we come back and check which one is or the answer. But for this exercise, we will go through all of them, and I hope you all went through all of them. So the first one is asking you, what is the sample size? Did you calculate the sample size? What was the sample size? Peter says it's 200. So yes, the sample size is 200. So Peter says it's 200. Yes. So this should have been 200. What is the expected value? Your expected value, remember, it's your probability times your n. So if our total was 200, so it means we use 200 to calculate the expected value. We'll say 0.2 multiplied by 200. It should give us the expected value for 1. And what is the expected value for 1? 200 multiplied by 0.2 will give us 40. And 0.4 multiplied by 200 will give us 80, and so forth. So it means 0.3 multiplied by 200 gives us 60. And 0.1 multiplied by 200 will give us 20. Then it means number 1 was the incorrect one and number 2 is correct. And the question says the region of rejection at 5% level of significance is 7.81. Did we go and find this critical value, region of rejection? Did we go and define it? So it means we need to go find the critical value, which will also have to answer number 4 when we go find that critical value as well. And the critical value is 0.05 because it's 5%. And you go and find our degrees of freedom. Remember, degrees of freedom is n minus 1. 1, 2, 3. Therefore, it is 3 minus 1, which is, it's 4, sorry. 4 minus 1. Therefore, the degrees of freedom is 3. So we're going to use 3 to go to the table. Then we go to the table. We go to the table. We come to the table and we look for chi-square 0.05 here at the top, and the degrees of freedom equals to 3 on the side. So we go look for 0.05, which is that 0.05. Then we go look for degrees of freedom 3, is that one where they meet, and that is 7.81. And it says at 5% level of significance, our chi-square, the region of rejection at the alpha 5% level of significance is chi-square greater than 7.81. And that is correct because that's the region of rejection is greater than, because when we put the critical value we went and found, that is not the chi-square, like that. Our region of rejection, which we found 7.81, it says if it's greater than this, that's our region of rejection. And that's what we found. And that is the correct one as well. Our critical value is 7.18. It is not, because it was supposed to say 7.81. Our test statistic, if you would have calculated the test statistic, which is chi-square stat, you would have found that the sum of your observed minus your expected squared divided by your expected will give you 0.7667. And therefore it means that is also not correct. So we have 2 correct answers, which is number 2 and number 3. And I think that's what Peter said. Yes. So there should have been an errata. I don't know which option they would have submitted to the examination department to mark your paper, but yeah. And that's what we will have. 2 options that are correct. So you do picky and hope that the one you choose was the correct option they submitted to the exam department. Okay, there is your next question. Also remember, they give you your probabilities. All what they're asking you is to go find what the critical value is and also calculate the test statistic. You have 5 minutes to calculate and find the answer. You can post your options when you have your answer on the chat. So first you need to go find the critical value, and then you need to and then you will need to calculate the test statistic. And remember, critical value, chi-square critical value, we'll find it by using chi-square alpha and the degrees of freedom. In this instance, our degrees of freedom will be k minus 1 because they gave us k. And in this one, you will do the chi-square that as your sum of your observed minus your expected squared divided by the expected. Okay. What is the critical value? If we use alpha, we did go get this because it's the same as what we did previously, 0.05 and 3. 4 minus 1 will give us 3, and it will still give us 7,18. And if you calculate the expected value, for example, 0,15 multiplied by 150 will give you 22,5. So for this, the expected value will be 22,5. And for 50, the expected value for this will be 60, which is 0,4 multiplied by 150. And the expected value for 38 will give you 52.5. And the expected value for 24 will give you 15. So when you have your expected values, then you can come and substitute into the formula. And your expected value, your observed, will say 38 minus 22.5, and you square the answer, divide by 22.5, plus you do the same, 50 minus 60, the answer you square, divide by 60, plus you do all of them, and you calculate, and when you've done, the answer you will get will give you 21.7492, which makes option number 1 the correct answer. And that concludes our first half of the session. And there are more exercises that I have on here. So what I will do is I will keep this exercise open, and I'm going to also give you a 10 minutes break. We will meet again at 4 o'clock when we do the hypothesis testing for independence or for a contingency table. While you're still on break, please make sure that you go through this exercise, and the answer we can discuss on WhatsApp. But I'm going to just leave it on the exercise that you can work on it. And then I will see you at 4:30. At 4 o'clock. Exactly 4 o'clock. back to your second session. We will start in 1 minute. I hope you were able to answer this question that I posted here. Because it just wanted you to calculate the frequencies. Okay. Otherwise, then we can take it up on the WhatsApp group as well. Okay, we're going to continue and look at chi-square for independence. So far, we looked at chi-square for goodness fit of test. It's when you are given only one column with all the frequencies. Now we're going to look at using a cross tab or a cross tabulation to do the same test that we have just completed. So we're going to learn how to use contingency table to do chi-square for independence. And to do that, when we test for independence, the null hypothesis and the alternative hypothesis have to be one of the opposite of one. So null hypothesis, you will state it by saying two categorical variables are independent, because we're using categorical variables like age and gender. So because age is independent from gender, or we can test whether age and gender are independent from one another, or whether people prefer to buy white bread than buying brown bread. And if those people, if female or males, do prefer that. So you can do the hypothesis on the bread preference and gender and check if that categories are independent. The alternative will state that the two categories or the two categorical variables are dependent, meaning they are related to one another. There is a relationship between the two variables. That's the null hypothesis. Our test statistic that we're going to use in order for us to make decision based on that is the same as the test statistic that we looked at. We're still going to look at your observed minus your frequency, but this time our frequency will be the frequency of the contingency table. I will show you also how to calculate this the expected frequencies as well. And the degrees of freedom, when we go find the region of rejection by using the critical value, when we go to the table, it's different to when you use goodness of fit test. On this one, the degrees of freedom will be the number of rows minus 1 times the number of columns minus 1. And we use that to go find our critical value together with the alpha or level of significance value. And when we have that, this is the formula we use to calculate the expected frequency. To calculate the expected frequency, we use the row total multiply by the column total, divide by the total, the grand total, or your sample size n. To make a decision, when the test statistic is greater than the critical value that we would have found on the critical value table, we reject the null hypothesis, only if it's above. The same, we will go and find the region of rejection, which is your critical value, which will be your alpha and your degrees of freedom. And if it falls in the rejection area, we reject the null hypothesis when it falls in there. Otherwise, we do not reject the null hypothesis when it falls on the white area. Let's look at an example. Let's say we have the meal plan of 200 students shown. And we have their class standing as a category and also the meal plan. So some prefer 20-week meal plan, some prefer 10-week meal plan, and some do not prefer any plan. And this is the contingency table. And in the exam, you might find that the contingency table does not have the total. Please calculate the total, which means the total is just for freshmen will be, you add 24 plus 32 plus 14 will give you the total of 70. For 20 per week, 24 plus 22 plus 10 plus 14 will give you 70. N, which is our grand total, this will be our N, or our grand total is 24 plus 32 plus 14 plus 22 plus that until 10, it will give you 200. Or you can just add all the total for the row, or you can add the total of the column, because 70 plus 88 plus 42 will give you 200. With everything, remember your hypothesis testing. From that table, if we need to test, our meal plan and class standing are independent. Always in your null hypothesis, it will state they are independent. The alternative will state the meal plan and class standing are dependent. Then we need to calculate the expected values, because we need to go find the expected test statistic. We need to calculate the test statistic. Remember your expected value, row total multiplied by column total, divide everything by n. So it means if I want to calculate for 24, my row total for 24 is 70. So my row total will be equal to 70. And my column total will be equal to 70. Divide that by my n, which is 200. And therefore that will give me 70 multiplied by 70 divided by 200, it will give me 24.5. And that is for 24. What if I want, and then not what if, then you have to calculate for each and every one of them. For 32, the row total, for 32, it will be 70 multiplied by the column total, which is 88, divided by 200. And that will give you 30.8. And for junior 10, to calculate the row total for, to calculate the expected value for 10, it will be 30 multiplied by 70 divided by 200. And you complete the whole table, and you will notice that I've already completed it. And there are my expected values: 24.5, 30.8, 14.7, up until 8.4. And those are my expected values that I'm going to use on the test statistic formula. Then to calculate the test statistic, remember your observed minus your expected. For number one, observed is 24 minus 24.5, square the value or the difference, and then divide by 24.2. And you do for all of them. Number two was 32 minus 30.8 square divided by 30.8 plus until you get all of them, until you get to 10 minus 8.4 square divided by 8.4. And the answer will give you 0.709. And that is your test statistic. When we have our test statistic, we go and find the critical value. Let's say they give us alpha of 0.05. So we go find the critical value, alpha, and the degrees of freedom. And we know that our alpha is 0.05 and our degrees of freedom Remember, our degrees of freedom is row total minus, number of rows minus 1 times the number of columns minus 1. So if we go back to this table, if you look at this table here, we can count how many number of rows we have. We have 1, 2, 3, 4 rows. And how many number of columns do we have? 1, 2, 3 columns. We don't count the totals. So we have 4 rows and 3 columns. Then we go. We say we have 4 rows minus 1 times 3 columns minus 1. And this gives us 4 minus 1 is 3 times 3 minus 1 is 2. Therefore, it means 3 times 2 is 6. So our degrees of freedom is 6. And when we have our degrees of freedom of 6, so we need to go and find the critical value on the table. Okay. Go to the table. We're looking for the chi-square test 0,05 and the degrees of freedom of 6. And we know that the degrees of freedom of 6, we're going to find it on the left, and this we're going to find it going down. So 0,0 is that, and 6, and where they meet, that is our answer. And the answer we have is 12,6. And because the table I took the value from was 3-digit table, so I have 12,5, but the same as 12,6. So you go find the critical value, and we can go and make a decision, because now if we look at our critical value of 12,6, this side will be our rejection area, and therefore we can go and find where this value falls, and it will fall somewhere in the do not reject area. Since it falls somewhere in the white area, we can conclude, or we can make a decision by saying the test statistic of 0,709 is greater than the chi-square test of the chi-square critical value of 12,59 or 12,6. So we do not reject the null hypothesis, and then we conclude by saying there is no sufficient evidence that the meal plan plus standing are related at 5% level of significance, and that's how you make a decision. Any questions? Do you have any question? Okay, in the absence of questions, that concludes what I was supposed to share with you. Now it means it's your time to do the exercise, so it gives us more time. If you look at that table, you will notice that there are missing information on that cross table. Or what they want you to do is, for this, make it easy, is for you to complete the whole table. This is the total. How do you get the number of female? It means it is the total minus the males will give you the female. Same will apply. How do you get the female total? Yeah, you cannot get the female total if you haven't calculated your females or you haven't calculated your Indians. So you will need to calculate female value and calculate this to get that value. So that's what they want. And then the options as well, if you look at them, they're looking for the incorrect value. But please go through the whole statement and see if you understand what the question, the options are asking you to do. So the first two are asking you for the null hypothesis and alternative hypothesis. Option number 3 and option number 4 and option number 3 and 4, they are asking you about the information on the table. So you will have to calculate the information on the table first. Then option number 5 is asking you to calculate the expected value. Please calculate the expected value for the whole table because then you're going to take more time and we need to do other exercises. Let's only calculate the expected value for this. And we know that the expected value is your raw total multiplied by the column total divided by A. And once you have that, then you will have the answer. So you have 5 minutes to do this. It's easy, complete, and then answer the questions. We're only going to look at the questions. I'm not going to ask you to give me the answer for the table. And we're just going to run through the questions. So 5 minutes. Okay, so if you all went through the options, let's see on. So I'm gonna run through the questions and you're going to tell me, because you decided not to talk to me, you will talk to me via the chat. So I'll run through the question and you tell me whether number 1 is correct or not correct. Okay, since we decided this is going to be our way of talking to one another. So complete the missing values. Which one of the following statement is incorrect? Number 1, the null hypothesis, the two variables are independent. Correct or not correct? Is number 1 correct? You can do a thumbs up if it's correct, and you can do a thumbs down if it's not correct, or you can type the word correct or C. Number 1. Okay. I see yes. Shola, thank you. Says it's correct. Number 2, is number 2 correct or incorrect? The statement number 1, if number 1 was correct with independent, therefore it means number 2 is also correct, because null hypothesis should say independent, then the alternative will say they are dependent. And number 3, the number of 8 cases that were white female is 1,971. So we're looking for this value here. Looking for that. Is that correct or incorrect? Number 3 is correct, because 12,534 minus 10,563 will give us 1,971. So 12,534 minus 10,563 will give us 1,971. So that is also correct. Number 4, the number of 8 cases that were Indian. The number of 8 cases, therefore it means we're looking for this answer here. So if you would have calculated the number of black and female, if you added those male and black, male and female, if you add those two values, you will get the answer for this, and you take 496 minus that and minus that should give you the Indian. And Overgang says, oh, 4 is also correct. So 4 is also correct. So which makes the expected value for black males is this. So if we take if we take the total, which is the plus that I have there, the total there, and we also take the total here, which is the other plus, we multiply them together, divide by the grand total of 42496, we should not get 14, we should get a number lower than that or higher than that. And that is why Jola said number 5 is the incorrect one. So number 5 is the wrong one. Your next exercise. So on this exercise, they give you the data. They said the calculations were done in Excel, and these are the results. They give you the data. This is our alpha. This is our alpha. They also give you the number of rows, the number of columns. and they calculate the degrees of freedom. And in this instance, if they calculated this degrees of freedom, it means they used R minus 1 times C minus 1. And they calculated critical value. So if this was our alpha value, so it means the critical value, they went and found that the critical value was 0.05 and the degrees of freedom of 2 to get this critical value. So they went to the table and got the critical value, which is 5.9915, and they calculated the test statistic, which is the chi-square, stat, which they found there. So now when you have all this information and they say now at alpha level of 5%. So now they say ignore what the alpha they have there and the alpha that they have there. If the alpha now becomes 1%, which one of the following statement will be correct? The nice thing is they calculated your test statistic. So all what you need to do now is to make a decision. This is a decision, that is a decision, a decision. So you will use 1% alpha, so it means you go and find the critical value with 0.01 and the degrees of freedom of 2. You go find this critical value on the table, and then we can come and do and make a decision and determine where is our region of rejection. Going to determine our region of rejection there, and anything that falls in the shaded area will be rejected, and anything that will fall there will be rejected based on that level of significance. Then the other thing, that's all what they're asking you. And you must look at this. This is positive side. This is positive side, and this side is the negative side. So you should be able to answer all these. Okay, so let's answer the question. And we are already into the second part of the session. So we are in the last 30 minutes of the session. We'll have one more exercise, and we will be done. So this is your exercise for now. Okay, so let's do the answer. Okay, like we've been doing, I'm going to run down the questions. You tell me whether it's correct or incorrect. Okay. Number one. Before we answer number one, actually, and number two, let's go find number, the last one, number 5. We can start by number 5. Find the region of rejection, which is the critical value. So did you go find the critical value? What was the answer for your critical value? I didn't check. What was the critical value that you found? You can type it there. What was the critical value? Or you can say it out loud. Critical value. So nobody went to find the critical value. Okay. Shola says the critical value was 9.21. You want to find the critical value and it's 9.21. So if the critical value is 9.21, therefore it means number 5 is incorrect. Oh, sorry, not number 5 is incorrect, because number 5 is asking the region of rejection critical value will be less than 5.9915. So it is incorrect because the region of rejection is 9.21 because we're using a 1% level of significance. Number 4, the chi-square test statistic is negatively skewed. Does this look negatively skewed? If you're not sure about the distribution of the chi-square, you can look at the picture from your table. If we look at this picture, it shows you that this is positively skewed. So therefore it means number 4 is also not correct. The degrees of freedom will be 5. Already the degrees of freedom, they calculated it there, and they didn't ask us to change that information. Therefore, that won't be correct. So then it leaves us with number 1 or number 2. If this is our test statistic, where does it fall? It falls in the area of rejection. So therefore, it means we reject the null hypothesis. The first one said we do not reject the null hypothesis. Therefore, number 1 will be incorrect, which makes number 2 the only correct information because we reject the null hypothesis. Any questions? Yes, Shola, answer is number 2. The last exercise, and then it will take us to the end of the session. You have the 2 tables, one with the observed and the other one with the expected frequencies. And what they're asking you is to find the correct answer. In this instance, actually in this instance, I just want you to find the answer without going through a whole lot of answering 1 to 5. Just tell me which one is the incorrect answer, which one is the correct answer, and post it on the chat. And as soon as I see 2 or 3 answers, then we conclude and we can call it a quit for today. So which one is the correct answer? And if by 5 you haven't found the answer, we can take the discussion offline, because it might take you longer to calculate the chi-square. Okay, so were you able to find the answer? So the test statistic, you calculated it. And I'm going to go through your answers as you gave me. None of the answers are correct. That's what Peter said. And he said the test statistic is 4.9642. There we go. As you can see there, the test statistic there is not the same as what you have calculated there. The last two digits are different. And did you go find the critical value? And we said the critical value, probably this is a typing error. But then if the critical value is 7.79, so this will be the incorrect one. So this might have been just a typing error where they typed 2 instead of 4.2, they did 2.4. So option number 3 is the incorrect one. And option number 2, there are no 6 degrees of freedom because there are 2 rows and 3 columns. So it is 1 multiplied by 2, which is 2, so that will be incorrect. And when they state the null hypothesis and alternative hypothesis, it should say there is no association with the null hypothesis, and the alternative should say there is an association. So they swap them around there. And if we have our critical value as 7.71 and our test statistic is 4.9, so therefore it means we do not reject the null hypothesis. So therefore it means that would have said that is correct. That also says correct, because the final answer says there is sufficient evidence to reject the null hypothesis. No, we do not reject the null hypothesis, because then the 4.6 falls in the do not reject. So we do not reject the null hypothesis. We do not reject the null hypothesis. So therefore it means option number 4 is the correct answer that you are looking for. So only option number 4, that was just the typing error of the numbers. But option number 4 will be the correct one. Okay, and that concludes today's session. The critical value, now you are confusing me. Peter said it's 7.79 and you're saying it is 4.61. Okay. And degrees of freedom is 2. and 0.1, and that is the critical value of 4.61. So there are two questions that almost look exactly the same. And then I will assume that that is then the right one, the way they put it, because then it means if we're going to say it falls here, it will be 4.61, the area of rejection. Therefore, this is correct. Sorry. Then you will have two questions, three answers that are correct, because if it falls on, if that is 4.69, it will fall somewhere in the rejection area. Even if this is 4.61 and we only look at the two-digit numbers, then this becomes 4.69. It falls in the rejection area, and therefore there is enough evidence to reject because we will be rejecting. Therefore, this will be correct as well, and that will be correct, and that will be correct. The only incorrect things will just be 1 and 2. So then this question raises a lot of eyebrows, because then there is no correct answer, one correct answer, like as Peter said. They didn't make, yeah. But even if it's not a typo for that matter, and you still calculated your test statistic and you found your test statistic as 4.96, it will still be rejected. You will still have two correct answers, because number 5 will be correct, because you will say there is enough evidence to reject because it falls in the rejection area. So yeah, so I'm not sure what quality assurance they do on their question papers before they submit them for the examinations as well. But that concludes today's session. If you have any other question, I am checking the post. Is there any other question? We have 4 more minutes left and then we're done. So I had another extra exercise. You can look at it, or you can go through your past exam papers as well. To recap, we looked at how we do chi-square for goodness of test, fit test, and we looked at how we do the hypothesis testing and how do we find the critical values and calculate the chi-square test statistic and then make a decision. Then we also looked at chi-square for independence, where we looked at how we find the expected value, how to calculate the chi-square test, how to state the null hypothesis and the alternative hypothesis, and how to find the critical values for the chi-square test, where we use the degrees of freedom, which are R minus 1 times C minus 1, which is the number of rows minus 1 and the number of columns minus 1. And then we also looked at how we make a decision and conclude. And that completes today's session. Remember, on Saturday, we have a session, but your session will be part of the first year statistic session. So you will need to join the channel that says first year statistic. I am not sure. Let me stop the recording. Then I will show you just now where to find